Yes, sir.
The first connection should be VCC, the power supply, positive should be connected here and negative should be grounded here, right? So let us see the connection. This is positive, positive is connected to VCC. The second connection is negative, that should be grounded. You can see that a wire is taken from the negative of the power supply and grounded here. Done?
Yes.
Next connection should be the positive feedback. You can see that there are two stages here. Okay, so but we have to take from the single state, that is the output from the collector of the first stage, right? So this is the place where we get the output from the first stage, and that should be connected as a positive feedback to the input again,
Yes.
right? And pause.
Start it, sir.
And the third connection must be from tank circuit to the input of the common emitter, which is base, right? From the end of the tank circuit to the input of the common emitter, which is base.
Yes.
Yes, a wire is taken from the CRO channel 1, wire is taken from the CRO channel 1, and that is connected at the end of the oscillator, which is positive should be connected at the collector and negative must be grounded,
CRO.
right? And once you switch on the CRO, you can see a sinusoidal wave on the screen, and we have to calculate the frequency of that sinusoidal wave. It must be around 2.5 to 3 kilohertz. It ranges from 2.5 to 3 kilohertz, right? Right?
Yes, sir.
As I told that the frequency of the wave which we get on the screen is around 2.5 to 3 kilohertz. That is the first part, and the second part is that we have to check the phase shift. That is the phase shift of the RC network, which is a tank circuit here, right? So as I told you that each RC network will give us 60 degrees phase shift. As we have 3 RC networks, the phase shift should be 180 degrees. So we are going to check whether we are getting the phase shift of 180 degrees or not. Okay, so a wire is taken from the output of the function generator. The positive of that is connected to the positive of the CRO channel 1, and negative must be connected to negative of the CRO channel 1, right? And the input here must be the same which you got at the first phase, like which we got, that should be around 2.5 to 3 kilohertz, right? So let me say some typical number 2.7. So keep it as 2.7, right? And that must be connected at the input of the tank circuit. Positive is connected at the top and negative is grounded. The CRO channel 2 is taken, and that should be connected at the end of tank circuit. Okay, you can see that there is no connection here between this and this. It's an open circuit here. So we have to connect. A wire here. Okay, and we have to connect the CRO channel to positive here, and negative must be grounded. It means that all the 2 channels of the CRO are connected here, right? Channel 1 is for input and channel 2 is for output. Once you switch on this CRO, you can see that the input wave and also the output wave, but the output wave will be 180 degrees out of phase with the input, which shows that there is a phase shift of 180 degrees. Okay, and this is the times per division, right? And we have XY, the swap option here. We call it swap XY, which will swap input and output. So take this knob to XY. You can see ellipse here, right? On the screen you can see the ellipse. Calculate the A and B values. You'll get the B value as 0 and some A value there, right? Only for the frequency which you gave here, which you got in the previous first phase, right? So which we give here, which is 2.7. For only that frequency you can see that the B value is 0. For all other remaining values you will surely get the B value as some number there, except 0. It means that there will be phase shift only for that particular frequency, 2.7 kilohertz, not for all other frequencies. That is about RC phase shift.